Man, I just didn't read the first paragraph enough. It's literally the first paragraph. Combustion, according to what has been already said in the first part of this work, is the decomposition of oxygen gas produced by a combustible body. The oxygen which forms the base of this gas is absorbed by and enters into combination with the burning body, while the caloric and light are set free. Every combustion, therefore, necessarily supposes oxygenation, where, on the contrary, every oxygenation does not necessarily imply concomitant, concomitant. Welcome back to English pronunciation. Concomitant combustion, because combustion, properly so called, cannot take place without disengagement of caloric and light. Before combustion can take place, it is necessary that the base of oxygen gas should have greater affinity to the combustible body than it has to caloric. And this elective attraction, to use Bergman's expression, can only take place at a certain degree of temperature, which is different for each combustible substance. Hence, the necessity of giving a first motion or beginning to every combustion by the approach of a heated body. The necessity of heating any body we mean to burn depends upon certain conditions, which we have not hitherto been attended to by any natural philosopher, for which reason I shall enlarge a little upon the subject in this place. You know what? I might just read this whole chapter. Nature is at present in a state of equilibrium, which cannot have been attained until all spontaneous combustions or oxygenations possible in the ordinary degrees of temperature had taken place. Hence, no new combinations or oxygenations can happen without destroying this equilibrium and raising the combustible substances to a superior degree or temperature. To illustrate this abstract view of the matter by example, let us suppose the usual temperature of the earth a little changed, and that it is raised only to the degree of boiling water. It is evident that in this case, phosphorus, which is combustible in a considerably lower degree of temperature, would no longer exist in nature in its pure and simple state, but would always be procured in its acid or oxygenated state, and its radical would become one of the substances unknown to chemistry. By gradually increasing the temperature of earth, the same circumstances would successively happen to all the bodies capable of combustion, and at last, every possible combustion having taken place, there would no longer exist any combustible body whatever, as every substance susceptible of that operation would be oxygenated and consequently incombustible. There cannot therefore exist, so far as it relates to us, any combustible body, except such as are incombustible in the extraordinary temperatures of the earth. Or what is the same thing, in other words, it is essential to the nature of every combustible body not to possess the property of combustion unless heated or raised to the degree of temperature at which combustion naturally takes place. When this degree is once produced, combustion commences, and the caloric, which is disengaged by the decomposition of oxygen gas, keeps up the temperature necessary for continuing combustion. When this is not the case, that is, when the disengaged caloric is insufficient for keeping up the necessary temperature, the combustion ceases. This circumstance is expressed in common language by saying that the body burns ill or with difficulty. Although combustion possesses some circumstances in common with distillation, especially with the compound kind of operation, they differ in a very material point. In distillation, there's a separation of one part of the elements of the substance from each other, and a combination of these in a new order, occasioned by the affinities which take place in the increased temperature produced during distillation. This likewise happens in combustion, but with this further circumstance, that a new element, not originally in the body, is brought into action. Oxygen is added into the substance submitted to the operation, and caloric is disengaged. The necessity of employing oxygen in the state of gas in all experiments with combustion, and the rigorous determination of the quantities employed, render this kind of operations peculiarly troublesome. Almost all the products of combustion are disengaged in the state of gas, and it is more difficult to retain them than even those furnished during compound distillation. Hence, this precaution was entirely neglected by the ancient chemists, and this set of experiments exclusively belong to modern chemistry. Having thus pointed out in a general way the objects to be had in view in experiments upon combustion, I proceed in the following sections of this chapter to describe the different instruments I have used with this view. The following arrangement is formed not upon the nature of the combustible bodies, but upon that of the instruments necessary for combustion. That's that chapter.